So let's talk about density. Density is the property of things that deals with floating on water or sinking in water, and it also deals with whether they will um, float or sink in each other, like why oil floats on water and all that kind of thing. So you should have done this PBS sort of interactive thing that I assigned. And notice here's a block, and this block has a certain mass. Okay. And I can make that mass more or less by sliding this bar. So you should have done this. And if this will float in this liquid, you may predict that as I add more mass and don't change the volume, it'll get to a point where it'll sink. Okay. But that doesn't mean that mass is exclusively the reason why something sinks, because now notice here's a mass where it sinks. And if I increase the volume, now it'll go back up. So it's a matter of how much mass there is per area, right? So here there's a mass for a large area. There's a mass for a small area, so that sinks. Okay. The other thing we can do is adjust the density of the liquid here with the slide bar and make it so that the block would sink. So if we want the block to sink, do we want the fluid to become more dense than the block or less dense? Hopefully it makes sense that as the fluid becomes less dense, then the block will sink. And as the fluid becomes more dense, then the particles of the fluid are closer together and they can push that block up. And then we can make the block more dense than the fluid, maybe by manipulating those things. What you can do is make the volume really large all at once, and then it splashes out as a column of water. But I'm not going to be there. It goes, watch this. Boo. All right. This is how I spent my summer. All right. So if we do gold, then gold will sink. If we do wood, then wood would float and all that. So that all has to do with density, and density is the mass over the volume. So it has to do with the mass, like we saw, the grams, and it also has to do with how much space it takes up the volume. So mass, remember, this is a very unit-driven topic. So mass is pretty much in grams, and volume is going to be in milliliters or centimeters cubed for this for when we're doing these questions. So one way to remember that density equals mass over volume is this little mnemonic where D equals a heart, and you see in the heart that this looks like an M and that looks like a V. So it's M over V, mass over volume. The other thing you can do is memorize this triangle. Density is equal to the mass divided by the volume, and mass is equal to the density times the volume, and volume is equal to the mass divided by the density. So that all is how that works. So let's look at a sample problem, shall we? We have 35 grams, so that's our mass, and we have a density of 14 grams per centimeters cubed for lead, and the question is how much volume? So what is the centimeters cubed in this case that it takes up? So there's a few ways to do this. You can remember that density equals mass over volume and just plug everything you know in. We know the density, so we know 14 grams over centimeters cubed will equal the mass, which is the 35 grams, and the volume, which we don't know. So that'll be our X. So you could do it that way. You could also do it by remembering that triangle. So that triangle tells us that density equals mass over volume. So our mass is 35 grams and our density is 14 grams per centimeter cubed. So to find our volume, we're going to divide 35 by 14. And another way, yet another way you can do that is we have the 35 grams, and we're going to want to cancel out grams and go to centimeters cubed. So we're going to use this thing, and the 14 is what the grams and centimeters cubes equals 1. So it divides by that way. So those are 3 ways to do that problem. Doesn't matter which way you do it, you're going to get the same answer either way, which is 2 point something, which I'm doing on my calculator now. 35 divided by 14 is 2.5. So 2.5 centimeters cubed are your units. Okay, so now gold has this density, and there's a cube, and that cube is going to measure 2 centimeters on every side. So this is 2 centimeters, and this is 2 centimeters, and this is 2 centimeters. So this one here, and this front one, and this one going up and down. And since they're all 2 centimeters, guess what that means? The volume of it, since it's centimeters cubed, means we have to multiply all the 2's. 2 times 2 times 2. 2 centimeters times 2 centimeters times 2 centimeters is 2 cubed centimeters cubed, or 2 times 2 is 4 times 2 is 8. So 8 centimeters cubed is the volume of the cube. And if we were in person, I could do all sorts of fun stuff with this, where you could explore with that. But anyway, so what's the mass of the cube? So if we have the volume, right, here's our volume, and we have a density, so we can use this thing. The mass is equal to density times volume. So density times volume will give us our mass. So the density is 19.3 grams per centimeters cubed. And then we're going to multiply that by the 8 centimeters cubed. And then look at this, centimeters cubes cancels. We get grams. Very nice. 19.3 times 8. 19.3 times 8 is 154.4 grams, which for significant figure wise, this is officially, since this has 2, this is 2 significant figures, and that has 3 significant figures, so that should be 2, so it would have been 150 grams with significant figures. All right. Another thing about density is it's what we call an intrinsic property, which means it doesn't matter how much material you have, it'll be indicative of that material. That will be a property that is true. So you see here a list that of substances, and it doesn't tell you how much things are, in this case, cork or butter. It doesn't tell you how much of this stuff there is. The density is the same. So seawater has a density of 1.025 grams per milliliter. Lead has a density of 11.35 grams per centimeters cubed. It doesn't matter how much lead you have because it's an intrinsic with an I property. So these things, if you had 2 liquids here, so if you had mercury and you had water, it would make sense that the water would be on top of the mercury. It has a lower density. So that means these particles are more close together and they'll push that water up. Whereas if you put water with kerosene, the kerosene will float on top of the water because it has a lower density. So remember, water is 1. Unfortunately, they went to 3 significant digits here, but sort of a general rule in your scientific life is that water is 1 for its density.